makes it awkward. Sorry, guys. All right, so when you have your graph paper, right, the parts that you are going to be graphing or plotting, all right, are your masses and your volumes. So this graph is going to be mass versus volume, all right? So what you want that we did in earlier periods was we went ahead and we drew our axis. We used rulers. I do have rulers up here in this little box right in front of my computer, okay? So you want to kind of make your axes, or your axis first, okay? So, all right, once you have that, we're going to be plotting because what we want is we want it to be, we want it to correlate with density, which is mass divided by volume. So that means that we're going to put our mass on our y-axis, so mass in grams, okay? And then along our x-axis, I'm going to go ahead and put the word volume. I'm going to put milliliters, okay? Technically, it is the same thing as centimeter cubed, so we could have put that as well, all right? All right, so now I think the part where everyone overthinks is how do I spread out my numbers, right? So make sure you take a look at your data table, okay, and see what the highest number you go up to is. Otherwise, I'm going to plot mine to be the highest of both the extremes. So technically, you could definitely copy what I'm about to do, all right? So going up, I'm going to go ahead and say every box is going to be 5. And now I'm realizing that this paper is a little bit smaller than mine this morning, so hopefully this still works. So I'm going to go ahead and put, I went up to, and I said that was 10, right? So I'm just going to go ahead and treat every square as 5. And the problem that we ran into this morning was just that potentially your larger block, which most of us had the large block, the highest number that it would go up to would be 144 for your mass. And so technically, and let me see which group that was. That would have been if you had copper. If you had copper, yours actually goes a little bit higher up than that. So if you had the reddish kind of metal, it's okay. We're going to just kind of improvise. You're going to put a little light dot where it should be if you went off your paper. All right. So don't freak out if you kind of go above where you're supposed to go. All right. So we're going by 5s going up. Going across, you want to keep the scale, you want it zoomed in because the highest density that you should have, and most of us have, is 15.6 because the large cube was 15.6. So if you happen to have put 8, by the way, for the volume of the large cube, it means that when you measured it, you didn't line it up to the 0, you lined it up to the end. So you kind of dismissed half a centimeter there, and it made all that difference, okay? Because you put 2 centimeters as the length times width times height, whereas 2.5 makes it 15.6. Big difference there. So I probably will come around and have you guys adjust that, the 15.6, if I notice it, because it'll throw things off just a tiny bit. So, all right. So what I did going across was I went 1, 2, and I made that 1. So every box for me going across was 1/2 or 0.5. So remember, your x and your y axis don't have to go by the same numbers. It's actually better to not do that because you want it to be scaled to best show your data. I'm going to stop mine at 16. So I know it doesn't go above 16. If you happen to have a volume that's higher than 16, please let me know and I'll come look and tell you where to correct it. All right. So you can get that scale made. And the next task that you're going to be doing, okay, once again, if you didn't calculate all the individual densities, you're going to want to go back to that just to make sure that you have them done so that I can kind of look over your data for you and help you out. But basically the next thing that we're doing is looking at your data table. This is your X, this is your Y. Each one of those is an ordered pair, and you're going to plot each one of those. So for example, for me, I'll just go with the station that I did yesterday. So I had 42.61 over here. My volume was 15.6. .98. So 15.6, 11, 6.5, 5, and 3. All right, so those were, if that was my data, because that was at the station that I was at, okay, this is your X, this is your Y. So my first one, I would go over 15.6, up 42.6. So I would go over 15.6, so right about here, and I would go up to 42.6. So looking across, that's about right there. I'm going to put that dot there. I'm going to also label it number 1 because that was my sample number 1. That'll help you kind of go back and you know which one has the star next to it, and that way you can circle that one. And any one that I tell you to eliminate, but I think I had it all fixed by your guys' class. Yeah. Yep. So you're going to go ahead and plot all of those X and Y. Then the next step after that is you're going to use a ruler to make a best fit line, but I will kind of show you guys that part here in a few. Okay, so let me kind of walk around and make sure everybody's at this step, and then, like I said, I don't want to talk too long about this because I do need to run you guys through a couple notes, okay? Okay, so now I have all of mine plotted. I circled the one that was my weirdo, so it was a different type of metal, and I knew that just by observation. Also, when I calculated my densities, it kind of stuck out a little bit, okay? So I circled that. You have your ruler. What you want to do is you want to start that ruler at the origin, and I recommend everyone does that. In your later advanced classes, you'll learn that you don't always have to start it at the origin because a trend line should represent the data. All that you're seeing me do right now is I'm just kind of sliding this up and down. I want to draw a line that is going to represent all of the dots. If you circled more than one dot, because I told you to throw out a data point, ignore that other one too, all right? So you are ignoring the one that you circled. You do not have to hit dots. You're going to see that mine is going to hit. But it's actually preferable or preferred not to hit the dots so that you're not, biased towards any one data point and stuff like that. All right. So once you've drawn your line, okay, that represents your dots, then it's a matter of finding the slope of this line. You have 0, 0 is your starting point because I started it right at the origin. So as long as it goes into that corner, you have 0, 0. And then you need to find another spot along your line. So I'm just going to zoom in a little so you guys can see what I mean by this. I'm going to find a spot along my line where the grid kind of crisscrosses it. All right, so I'm thinking this looks like an excellent spot. So what you see that I pointed at, or what I circled, was a spot where the grid lines are actually crossing exactly at a point. So find that point, write your ordered pair for that. So here I'm looking at mine. I have 9, and I look across, 25. Okay, so that's my ordered pair, and that's going to be what I use for my slope. Okay, so the next step, once you've done that, is you're going to be doing your slope formula. So you would do y2 minus y1 over x2 minus x1. Now that looks really crazy, but realize that I told you to start it at the origin, which means x1 and y1 are zeros. Yay! I made it easier for you. So what I'm going to put here is I have 25 minus 0. So I put my y2 minus y1, and then I'm going to go x2 minus x1. So 9 minus 0. I'm going to solve for that. So I have 25 divided by 9, and that should give me my slope. All right, so 25 divided by 9, I got 2.77777. So I'm going to go ahead and round that up to 2. I think 8. I think I'm going to go up to, yeah, you should just go to the first decimal. 2.8, and then looking at what my units were on my x and my y means I'm going to have grams per milliliter. That's your unit for density. So I just found my density. So I had 2.8 was my density. So I had the shiny ones, right? So, okay. So now that I have that, now I can start looking at my post-lab questions. Okay, so it says in your post-lab to make sure you calculate your density, use your density equation to find your fifth metal. So we know density of our fifth metal was a different value. So for me, mine was 9.5. Okay, so I did that with my calculation. Okay, so I can see that it's a higher density, because if I were to draw a line up to that, that's a steeper slope. Okay, so it's all about the slope. Your slope is equal to your density. Okay. And then it says for number 3, it says what kind of trend or pattern is observed is obvious in the data according to your graph. So right here we have a positive slope, so going up our page. So if I have a positive slope, that means that as volume goes up, mass goes up. Is this a direct relationship or an indirect? Does anybody know? That is direct. Positive slopes mean direct. If it was indirect, it would have a negative. It would mean as volume goes up, mass went down. And that's not what happened, right? They're a direct relationship. So for your answer for number 3, you'll be saying direct, and you can relate it to that positive slope, okay? And then finally, the last thing, if you had a gold color on your metals, your actual was 8.3. It's not on your table, and I apologize. I think I keep telling myself every year to add it, and I still haven't. All right, so that should get you through that. Then you're going to do your percent error, which is what we did for your Rainbow Lab, and then write a little conclusion, okay? So that's it. Do you guys have any questions for me immediately? Otherwise, I'll give you guys a couple minutes to kind of work with your partners if you need to kind of get this settled in, and then we'll move on to the notes in a bit, okay? I'm going to stop the recording.